Hello, my name is Brian Palacios, and today I'm going to give you a short introduction on our presentation to the Cantor Set. I am presenting the Cantor Set, and so let's talk about the Cantor Set a little bit. So, let's see. We will be talking about these certain points right here. The Cantor Set in general, the history of the Cantor Set, the construction, how it's made, the tools, the length of the Cantor Set, it's how it's uncountable, some applications, and conclusions. Then references will be that is outlined for the project. So, what is the Cantor set? Well, the Cantor set, it's the definition, it's a set of points lying on a single line segment obtained by removing the middle third of a line segment and then repeating the process with the remaining shorter segments. So basically, you take a line for length 1 from 0 to 1, and then you're going to remove the middle third, and you're left with two lengths of 1/3 now. And those endpoints are the points that lie in the Cantor set. So you have an endpoint at 0, you have one at 1/3, you have one at 2/3, and you have one at 1, and that whole middle part taken away. Then we'll take both of those segments, and in each one, we'll take out from that one, the 0 to 1/3, we're going to take that line segment and take out a third. So we're going to be left with 0 to 1/9, and then that middle section is gone, and then so on and so forth. And we'll keep on doing that infinitely, taking more and more away from the Cantor set. So that means we're taking more points out of it. So the Cantor set was first introduced by German mathematician George Cantor in 1883. And he was born in Russia, but he moved to Germany, a mathematician, and real famous for the continuum hypothesis and contemplating infinity and how there's different sizes of infinity. So, why is the Cantor set interesting? Well, it has the length of 0, as we went over already. It's infinitely large. That means it's as big as the real numbers. So the real numbers is every single number that we could think about. So, and counterintuitively, we're taking away more from the Cantor set, but it's still as big as all the numbers, as all the real numbers. And it's bigger than just the natural numbers. So it's an interesting concept. And it's paradoxical in a way. So those are some short points that are going to be presented in our presentation. And this will just be the little intro. Thank you. My name is Brian Palacios once again.